Okay, so this is the last integration by parts lesson I'm going to give, and this is a special tricky case, usually for a product of an exponential and trig function, sine or cosine. And this is a case where we have to repeat integration by parts, and we actually end up seeing the same integral that we started with pop up again. And that's what's going to make this a little tricky, but it's also going to make it so that we can solve the problem. So let me just start with the simplest example of this phenomenon, and that would be just e to the x sine x. And it's worth noting here that the same procedure is going to work if I change this x to a 2x, a 4x, or a 5x, or any constant multiple of x, and this x could be any other constant multiple of x, and the same procedure will work. Now, I have to choose my u and my dv here, and technically it doesn't matter which one I pick, but I do need to be consistent when I go to the second iteration of integration by parts. So I'm going to let u equal e to the x here. dv equals sine x dx. Go through the procedure. du will be e to the x dx. v will be minus cosine of x. Now, let's apply the formula. uv minus the integral of v du. And we get minus e to the x cosine x, there's our uv, minus, now this minus and this minus will actually cancel and make it a plus, so let's just go ahead and skip that stuff. Plus the integral of v du, this will be cosine, positive e to the x cosine x now. And we have a very similar integral to the one we started with, but not exactly the same one. Now here's where consistency is important. I'm going to use integration by parts on this again, and I want to let u equal e to dx again because that's what I picked the first time. Had I let u equal sine x and dv be e to dx the first time, I'd want to do the same. I'd want to use those choices here as well. But I do want to use u equal e to dx because that's what I did on the first time iteration here. And dv will be cosine x dx. Let me just use the formula again. du is e to the x dx. v will be plus sine x now. And let's put that in for the integral. So this whole thing becomes minus e to the x cosine x plus its integral. We're going to use integration by parts to write this down. uv here is e to the x sine x minus the integral of v du. And here, we should notice that this is the integral that we actually started with. So, how are we going to finish the problem? Well, I'm going to turn it into an algebra equation. This entire expression is equal to the original problem we started with, which was integral of e to the x sine x. So here's the equation we want to solve for integral e to the x sine x. So when we write down the full equation, well, here it is. The integral of e to the x sine x dx is this entire mess here. So let me copy that whole thing down. Minus e to the x cosine x plus e to the x sine x minus the integral of e to the x sine x dx. I'm going to treat this integral of e to the x sine x as an unknown, as its own little variable, and solve for it. So I'd like to get all copies of it on the same side of the equation. I'm going to add this integral to both sides. That's going to give me two of them on the left-hand side. So this turns into double the integral we're interested in. Is negative e to the x cosine x plus e to the x sine x. And now I finish the problem by dividing both sides by 2. So, final answer, integral of e to the x sine x dx is negative 1/2 e to the x cosine x plus 1/2 e to the x sine x. And now's a good time to put on the plus c.